When the fiber is spinning, or when the yarn is weaving and dyeing, the yarn fiber in the fabric is stretched or deformed by external force, and the yarn fiber and the fabric structure generate internal stress. In the static dry relaxation state, or in the static wet relaxation state, or in the dynamic wet relaxation state and the full relaxation state, the release of internal stress of different degrees makes the yarn fibers and fabrics return to the original state. Different fibers and their fabrics have different degrees of shrinkage, mainly depending on the characteristics of their fibers. Hydrophilic fibers have a larger degree of shrinkage, such as cotton, hemp, viscose, and other fibers, while hydrophobic fibers have a higher degree of shrinkage, less, such as synthetic fibers, etc. When the fiber is in a wet state, it will expand due to the action of the immersion liquid, which will increase the fiber diameter. For example, on the fabric, the fiber curvature radius of the interwoven point of the fabric is forced to increase, resulting in a shortening of the fabric length. For example, cotton fibers expand under the action of water. The cross-sectional area increases by 40 to 50%, and the length increases by 1 to 2%, while synthetic fibers shrink by heat, such as boiling water shrinkage, generally about 5%. When the textile fiber is heated, the shape and size of the fiber change and shrink, and it cannot return to the original state after cooling, which is called thermal shrinkage of the fiber. The percentage of length before and after heat shrinkage is called the heat shrinkage rate, which is generally measured by boiling water shrinkage. In boiling water at 100 degrees Celsius, the percentage of fiber length shrinkage is expressed. Hot air is also used. The percentage of shrinkage is measured in the steam method, and the percentage of shrinkage is measured in the steam exceeding 100 degrees centigrade. Fibers behave differently due to different conditions such as internal structure, heating temperature, and time. For example, the boiling water shrinkage rate of processed polyester staple fiber is 1%, the boiling water shrinkage rate of vinylon is 5%, and the hot air shrinkage rate of vinylon is 50%. Fibers are closely related to the dimensional stability of textile processing and fabrics, which provide some basis for the design of subsequent processes. Thanks for watching. Follow my account and learn more lessons about textiles and dyes.